The robot vacuum cleaner is often described as a novelty that became useful, but its success suggests the opposite. It looks modest, moves slowly, and cleans incrementally, yet it has changed how people relate to one of the most persistent forms of domestic labor. To understand why it exists in its current form, it helps to start with what cleaning floors required before automation entered the room. Floor cleaning was historically reactive. Dirt became visible, discomfort crossed a threshold, and action followed. Whether using a broom, mop, or vacuum, the task demanded attention from start to finish. You had to be present, aware, and willing to interrupt whatever else you were doing. The tools improved over time, but the structure of the task did not. Cleaning remained episodic and effortful. Traditional vacuum cleaners optimized for performance under the assumption that cleaning was already happening. More suction meant faster results. Wider heads meant fewer passes. Attachments promised flexibility. But none of these improvements addressed the real friction point, the decision to begin. As homes filled with furniture, cables, toys, and irregular layouts, vacuuming became increasingly annoying. Each session required preparation, moving chairs, clearing paths, unplugging cords. The vacuum itself often lived in a closet, making retrieval a small but meaningful barrier. The result was predictable. People cleaned less often than they wanted to, not because they didn't care, but because the cost of starting felt higher than the cost of waiting. Early robotic attempts misunderstood this. They focused on replicating human cleaning behavior in miniature. Strong motors, complex arms, visible controls. These machines struggled because homes are not factories. Floors are not empty. People leave objects where they fall. They rearrange rooms frequently. They forget to prepare spaces for machines. The breakthrough came when designers stopped trying to replace the human and instead designed around human inconsistency. The robot vacuum does not assume a clean environment. It assumes a messy one. Its circular or low-profile shape exists not for aesthetics, but to survive collisions. Sharp corners catch, tall bodies tip. A disc can bounce, rotate, and recover. It can get under furniture where dust collects precisely because humans do not go there often. Its cleaning strategy is probabilistic. Instead of covering every inch systematically, many early models wandered. This was not a failure of engineering. It was an acceptance of reality. Given enough time and enough passes, coverage emerges. The machine doesn't need to be perfect in one session because it will return tomorrow. This is where the core shift occurs. Cleaning becomes continuous instead of episodic. The robot vacuum replaces intensity with frequency. It doesn't deep clean once a week. It lightly cleans every day. This aligns with how dirt actually accumulates. Most household dust is incremental. Skin cells, fabric fibers, tracked-in debris. By removing small amounts regularly, the machine prevents visible buildup without demanding attention. Suction strength becomes less important than reliability. Battery life matters more than power. Noise becomes critical because the machine must coexist with life, not interrupt it. A loud robot would be resented. A quiet one is forgiven, even when it bumps into walls or misses corners. Navigation technology evolved under these constraints. Early random movement gave way to mapping, not for precision's sake, but for predictability. Humans are more tolerant of imperfection when behavior feels intentional. A robot that appears to know where it has been feels competent, even if the end result is similar. The trade-offs are everywhere. Brushes are soft to avoid damage, even if that means less aggressive cleaning. Wheels are designed to climb thresholds, accepting occasional entrapment. Sensors prevent falls but introduce hesitation. Every choice favors persistence over dominance. The robot vacuum also changed human behavior in subtle ways. Floors began to stay clearer. Loose cables were lifted. Chairs were tucked in. Not because the robot demanded it, but because people adjusted to support a background process they valued. The machine shaped the environment, and the environment shaped the machine. Control interfaces reflect this philosophy. Scheduling replaced manual start buttons. Apps replaced switches. The goal was not to give users more control, but fewer decisions. Once the robot is trusted, it fades into routine. When it fails, it becomes noticeable again, often disproportionately so. This leads to a moment of realization. The robot vacuum succeeds not when it cleans exceptionally well, but when it stops being part of the decision-making process altogether. It does not eliminate the need for traditional cleaning tools. It changes the baseline. Floors are never pristine, but they are rarely neglected. The emotional burden of noticing dirt decreases. The threshold for discomfort rises. Cleanliness becomes ambient. The robot vacuum's current form is the physical expression of that insight. Small enough to ignore, quiet enough to tolerate, slow enough to coexist. It is not optimized for peak performance, but for long-term presence. This is the deeper lesson hidden in its design. The most effective automation doesn't replace human effort directly. It removes the need to decide when effort should begin. By operating continuously and imperfectly, the robot vacuum aligns with how people actually live, not how they imagine they should. When a robot vacuum gets stuck under a couch or spins briefly in confusion, it feels almost forgivable. It's not failing at cleaning. It's reminding you that its role is not mastery, but maintenance. That is the invisible design at work. A machine shaped not by the problem of dirt, but by the psychology of postponement. The robot vacuum exists in its current form because the hardest part of cleaning was never the cleaning itself. It was deciding to start.